Can you see my screen?
Coming. Yeah, user play model, please.
Yes. Okay.
Perfect.
Hello, everyone. My name is Pinari, and my partner name is Onatida. We are from KMITL, Thailand, and our research is the 3D stereographic endoscope for with automated image analysis for cervical cancer early detection. Okay, let's start with our problem. We concerned about the cervical cancer, which is the second ranking most found cancer in Thailand. And from the statistic, the number of deaths in Thailand in 2019 is around 4,000 cases. And from the statistic found that the number of patients is increasing every year. So we have to pay attention to this problem. And the diagnosis for cervical cancer can be done by three methods. The first one is the pap smear. The second one is the HPV virus examination. If the result of the first and second method is abnormal, we will go to the third method, which is the colposcopy examination. Yeah, for the colposcopy, is one of the method that have to insert the vaginal speculum into the cervix for keep it open during the diagnosis and using the colposcope for observe the walls or epithelial cell, which may cause the injuries and take long time processing. So we want to solve this problem and have an idea to create the 3D ColpoEye system, which is the 3D endoscope with artificial intelligence system. And these are our objective. Okay, first is to reduce the injuries by using small endoscope. Second, to shorten the processing time by create an artificial neural network system. And the last is to increase efficiency of diagnosis by using the 3D image technology.
In the part of methodology, we decided to use a CMOS endoscope, which is very portable, simple to use, good quality, and good resolution. And then we combine two CMOS camera together to achieve the 3D image. This technique that called dual camera technique. And we decided to use the dual camera technology with the handle. This is our hardware design that has the main requirements are the handle can be held properly and it had two tubes for insert the wires of two CMOS camera. And we have two 3D systems that we use. There are Anaglyph system and PolaRize system. We use them to be the mode or function in our ColpoEye system. The comparison between Anaglyph and PolaRize system, you will see that they are good in different purposes. For the Anaglyph system, it can be used in any type of image display, but it may cause the color absorption. For the PolaRize system, it can be see clearer than Anaglyph system, but it requires to use with a 3D monitor that built in the polarization system. Let's look at our workflow. By the time we using 3D ColpoEye, that is the name of our product, it will use the artificial intelligence or AI to analyze the image and show us the class of the cervical cancer that this cervix may be, and it show in the 3D mode by using deep learning of the object detection. And then we will show the result on the interface.
Okay, and next is the result. This is the graphic user interface that show the image from our 3D ColpoEye and show the result from the artificial intelligence. Okay, and this is the overall of our 3D ColpoEye system. You can see that the main part of the ColpoEye system is the ColpoEye, which is the part for observe inside the cervix. We also have the notebook PC and monitor for show the result, and we have the full switch for capture and save the image. And the last one is the comparison between the old colposcope and our 3D ColpoEye. First, we try to reduce the injuries during diagnosis to be less than the old one. For the time processing, we use the artificial intelligence to help the doctor diagnose faster. For the cost, the old colposcope is around three $30,000, but our 3D ColpoEye is around $4,000 to $5,000. And the last one is our strength of our 3D ColpoEye are having the 3D visualize and having the automated image analysis system. Okay, thank you.
Okay, great,
Yeah,
girl. You
thank
saved some
you very
money.
much for this talk. I think the talk is open for questions. Are there questions from the jury? Yeah, please, Luke.
Yes, this is very, very nice project. So congratulations. So you do the 3D vision and with the special camera that you designed. Now, it's not very clear to me how you do that. So normally 3D vision you can do with dedicated 3D depth algorithms, so using the cameras immediately and so on, and camera calibration. And you're saying that you're doing the TensorFlow models, the AI models. So the AI models, so to do that, you normally need a lot of images to train your model. So for getting these things that you want to detect. So I see that you have also the TensorFlow. So have you been, for the TensorFlow, have you been doing transfer learning to adapt your system to some other models? So what model did you use? Or did you start from scratch? So my question is twofold. So one is the dedicated 3D algorithms or the AI, or maybe it's a combination. So could you explain that, please?
In the software part, we use only TensorFlow model, and in the 3D we use dual camera, and we will overlap two image together in the specific distance that can be can be make the 3D image.
So you're using a dedicated algorithm for the disparity calculation, for the depth calculation. And then on that, you use your TensorFlow model.
Yes.
Okay, that's good. So, and what is the kind of objects that you are detecting with your TensorFlow model, with your deep learning?
I
Which model are you using that, or that you're are training? Is that mobile net, or is that
we use
ResNet?
ResNet. Yeah.
ResNet 50.
Yes.
Mm-hmm. So, and the objects that you detect, so normally to train ResNet 50, you probably need 1 million or 2 million photos.
Yes.
So where did you, how did you do that? You need annotated photos, of course.
We just request the image from the hospital and just not achieve the 1 million or high amount of the image, but we just use only small because it's hard to request because it have the part
the ethic parts to request the data from the patient. So now we have about 500 data. So now our object detection will train in around 500 data, and we will require more data, and now in the process that require the ethics from the hospital. Yes.
Thank you.
Okay,
Thank
there
you.
was one more question from Japan.
Yes.
Takekiza-san, please.
Yes, I have two questions. One is that you use a two camera endoscope, so that comes to the bigger size of the endoscope is one question. And another question is, your cost is cheaper than the conventional old endoscope. Why that your system can reduce the cost?
Because I found the CMOS endoscope that has the low cost, but it's good quality. The quality is similar to the colposcope that has the higher cost.
How about the size?
The pixels.
The resolution, right?
No, the diameter of the endoscope.
Wow.
So you use a
Around
two
8.
camera endoscope. That comes to the bigger size of the normal endoscope. Is that right?
Size.
This is around the size of the colposcope that we made is around 1.5 centimeters, the diameter.
So is it
Yes,
bigger than the normal endoscope, or that
Pardon?
smaller? So is your endoscope is smaller or bigger than the normal endoscope?
You mean the image, right?
No, no image. The actual diameter of the scope.
The question is
It's
about the
smaller
size
than-
of the larger.
Yeah, it's not bigger.
It's bigger.
It's smaller
It
than
is more, but it's not bigger. It's more. It can insert in the cervix.
So that we call that the CCD camera is smaller than the normal one.
Yeah, our 3D ColpoEye is smaller than the cervix size. But normally when we do the colposcopy, we have to insert the speculum for open the size of cervix first, and then we can put our 3D ColpoEye into the cervix.
Mm-hmm.
I understand your question. Right?
Yeah, okay, thank you.
Okay, thank you.
Yeah.
Other questions?
No.
No. Thank you for your presentation. So, Alice,
Yeah,
we
we
switch
move
to the next team.
one. Yeah.
Thank
Okay.
you.
Thank you.